Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at exponentiation and using exponentiation to solve functions, specifically equations that have different bases. So let's start off with the most basic of the types of problems that we can have. And these are going to be just two things that have different bases. So let's do 5 to the power of x equals 2. So what we're looking for is how many powers of x are going to give me 2? Now, in order to do this, we are going to create two exponents. This is the process known as exponentiation. And to exponentiate, we either put things into the common log base 10, or we put into the common log natural log base e. Now, I personally go into base e because it has two letters, but I'm going to do it in both so that you can see that you get the same ratio, just with two different bases. So let's start off with the natural log. We put the natural log in front of the base 5, and we put the natural log in front of the base 2. I then have the power come in front, and then we drop by dividing both sides by the natural log of 5. My solution is now an exact value, and it is the natural log of 2 divided by the natural log of 5. Let's go ahead and do the same thing, but we're going to put log base 10. Log base 10 moving in front, and I move the power in front using that third property that we've talked about in class, and then I divide both sides by log base 5. Once again, my goal is to create a proportion, a fraction, and that's now what I have. Now what you're looking at is also the change of base formula. So if I wanted to convert, let's say I had log base 2 of 5, and I want to change the base. I'm going to first make it a y. Then I'm going to exponentiate both sides so that I get 5 equal 2 to the y. And then I exponentiate again so that the natural log of 5 is equal to the natural log of 2 to the power of y. The natural log of 5 is now y natural log of 2, and when I divide, I now have changed my base from base 2 into base 5, or into base e, into base e. Okay? So you'll notice this is how I did my change of base, and this is how I solve by exponentiation. Let's try a little bit more difficult problem this time. So in the next level of the problem, we're going to have a binomial as an exponent. So let's now make it as 5 to the 3x plus 2 equals 26. Okay, we're going to use the common log. Once again, choose either the natural log and put it in front. That's what I just did. Or, for those of you who prefer, log base 10 of 5 to the 3x plus 2 equals log base 10 of 26. The power has to move in front, and when we move it in front, you must put parentheses. If you do not put parentheses, you most likely are going to always get these wrong. And that's because we have to distribute this natural log of 5 right here to both pieces inside of the parenthesis. I end up getting 3x natural log of 5 plus 2 natural log of 5 is equal to the natural log of 26. And I now want to move everything that doesn't have an x to the right side. I'm left with the natural log of 26 minus 2 natural log of 5 on the right and 3x natural log of 5 on the left. I'm now going to divide by everything except the x. That means a 3, a natural log of 5, go to the denominator, and x is now equal to the natural log of 26 minus 2 natural log of 5 divided by 3 natural log of 5. That's my solution. That's what we're looking for. The next level of problems have two binomials. Let's go ahead and say we have 3 to the 4x minus 2 equals, and let's do 5 to the 2x plus 1. We're going to put our natural log or log base 10 in front. We're then going to move the power in front, 4x minus 2, parentheses, natural log of 3 equals 2x plus 1, once again with parentheses, natural log of 5. I now have to distribute. So the natural log of 3 is being attached to the 4x and the 2, and the 1 and the 2x have natural log of 5. So 4x natural log of 3 minus 2 natural log of 3 is equal to 2x natural log of 5 plus 1 natural log of 5. I need to move the 2 natural log of 3 over, and I need to move the 2x natural log of 5 over. 4x natural log of 3 minus 2x natural log of 5 is equal to natural log of 5 minus 2, plus, as it moves over, it changes to its opposite, 2 natural log of 3. Now be careful, we are moving things from one side of the equal sign to the other, and to do that, we do change them to their opposites. I'm now going to factor out the x. Leaves me with 4 natural log of 3 minus 2 natural log of 5, and it equals the natural log of 5 plus 2 natural log of 3. The last step is to divide by the piece that's multiplied by the x. By dividing, I move it to the other side, and I have my solution.
Mr. Lee, if you're on campus, there's a student here for AP. She says it's supposed to open till 4. She came over from another school. So Mr. Lee, if you're on campus, it'd be great if you could come up to the office. Thank you.
Thank you, Mr. Lee. And you'll notice all I'm doing is rewriting my solution, making sure that I have it clearly written. Now, there's always a possibility of making things more difficult. I can't change that, and you have to be prepared for it. And the way they make these more difficult is they simply add more powers, more bases, and more terms that will be expanded when we have our exponentiation. So here, let's take a look at something that's a little bit more difficult. Let's go 3 to the second power times 2 to the 2x plus 1 is equal to 5 to the third power. We're going to start by exponentiating, which means I have 3 squared times 2 to the 2x plus 1 equals the natural log of 5 to the third. Because I have the times here, we have to expand this into more than one term. So we're now using our properties of logarithms and the expansion of logarithms to make 2 logarithmic terms. We put a plus in between. I'm now going to bring the power in front. So I'm going to have 2 natural log of 3 plus parenthesis 2x plus 1 close parenthesis natural log of 2 equals 3 natural log of 5. I'm going to move this piece over. I'm going to distribute the powers. I'm going to move another piece, and then I'm going to divide. So I've got 2x natural log of 2 plus the natural log of 2 equals 3 natural log of 5 minus 2 natural log of 3. Moving the natural log of 2 over, 2x natural log of 2 is then equal to, and I have 3 natural log of 5 minus 2 natural log of 3 minus natural log of 2, and I divide by 2 natural log of 2. 2 natural log of 2. X is therefore equal to 3 natural log of 5 minus 2 natural log of 3 minus the natural log of 2, divided by 2 natural log of 2. And this is my solution. You'll notice it isn't much different from what we've already seen. All that's changed is it's gotten a little bit more complicated. You notice it's not quite as complicated as this one. This one required us to do distribution twice. Here we only had the distribution once, but we had the expansion. So notice we're going to start adding expanding of the logarithm into multiple terms as we go through our exponentiation. Let's go ahead and take a look at one that's a little bit more difficult than this. Here we go. I have, let's do 2 to the 5th power times 3 to the 5x minus 2 equals 7 to the 2nd power times 5 to the 4x plus 6. Now, as you get better at these will go a lot faster. We're going to start off with the natural log, 2 to the 5th, 3 to the 5x minus 2 equals the natural log, 7 to the 2nd times 5 to the 4x plus 6. This gives me natural log of 2 to the 5th plus natural log of 3 to the 5x minus 2 equals natural log 7 to the 2nd plus the natural log of 5 to the 4x plus 6. Power moves in front. Natural log of 2. 5 natural log of 2 plus 5x minus 2 natural log of 3 equals 2 natural log of 7 plus 4x plus 6 natural log of 5. Now I can start moving things around if I wish, or I can wait until I'm done. I'm going to go ahead and distribute first, and then start moving things around. That's up to you. Once you get this far, it's just making sure that you use your law of equality correctly and that you factor without doing anything silly. So you've got to be careful. You've got to watch what you're doing and pay attention. This is going to have to move over. That has to move over. This piece right here moves this way. Okay. 5x to the natural log of 3. I'm subtracting 4x natural log of 5, and it's supposed to equal 2 natural log of 7 plus 6 natural log of 5 minus 5 natural log of 2 plus 2 natural log of 3. We're going to factor out the x. So we have x times 5 natural log of 3 minus 4 natural log of 5. On the other side, we have all of this, and we are about to divide. Natural log of 7, 6 natural log of 5, 5 natural log of 2, 2 natural log of 3. We're going to divide by 5 natural log of 3 minus 4 natural log of 5. And I now have my solution. It's a great big fraction. 2 natural log of 7 plus 6 natural log of 5 minus 5 natural log of 2 plus 2 natural log of 3 divided by 5 natural log of 3 minus 4 natural log of 5. And there went the lights in the classroom, always a joy. So here is my solution to this. Now, this is the first part of my solving, and it's going over the basic rules working with the exponentiation. I hope that helped, Hornets. Please remember, if you liked this video, please hit subscribe. If you have comments or questions, please remember to ask me questions. They can be answered in class, or just give me helpful hints on how I can improve. Thank you very much, Hornets, and I truly hope this helps. Thank you, be well, take care, and we will see you all in the future. Bye-bye now. Cheers.